Hello students, welcome to my channel, and this video we are going to discuss bases and their characteristics, means the properties of bases. So just like acids, the properties, some of the properties are reverse, but some are just like acids. Like they are good conductor of electricity and they also liberate heat. Exactly. So on diluting any base, it also liberates heat. Suppose why it conducts electricity, why bases conduct electricity, because it having ions. In acids there is H plus ions, in bases there is OH minus ions. So wherever the ions are present, they will conduct electricity or current. Now
when bases are diluted with water, they give out heat. Let's look at this experiment. We take 5 grams of sodium hydroxide pellets in a test tube. To this, we add 10 milliliters of water slowly by stirring. On diluting with water, some heat is released, due to which the test tube becomes warm. Let's observe the chemical behavior of these bases.
Chemical behavior?
yes,
Bases react with some metals, like zinc, and liberate hydrogen. For example, when sodium hydroxide reacts with a metal like zinc, it liberates hydrogen gas along with the formation of sodium zincate.
I don't see any gas. How can you say it's hydrogen gas?
The liberated gas can be tested with a burning splinter, which is put off with a pop sound indicating the presence of hydrogen gas.
What's next?
Bases react with non-metallic oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base.
and for a reminder, what is neutralization reaction? Neutralization means just like acids and bases. Just like acids and bases, you have seen neutralization reaction as well. And how is that so? Because when acids react with bases, what they give? They give salt plus water. So just like bases, just like acids, it also gives, right? And how is that so? Just note it down.
Hydrogen gas.
What's next?
Bases react with non-metallic.
Just like neutralization, just first T, the neutralization. When acid plus base, they react, they give what? Salt plus water. First thing is that they give salt plus water, and this reaction is called neutralization reaction. Why it is called? Antacid is given for any acidity is observed in any patient. So why it is called neutralization? When excess amount of acids are deposited or produced in our stomach, right, bases are given to neutralize the acid, right? And what it becomes? It becomes salt plus water. That is why it gets your stomach neutralized, and we get relief from acidity.
Oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base. From this, it can be concluded that non-metallic oxides are acidic in nature. Consider an example. When carbon dioxide gas is allowed to pass through calcium hydroxide, it results in the formation of calcium carbonate and water. Now, can you tell some of the uses of bases?
Yes. Bases neutralize the acidity caused in my stomach.
Yes.
Not all bases, only mild bases neutralize the acidity.
Mild
Apart from
bases.
that, bases have a variety of uses in daily life. Let's look at some of them. Bases like sodium hydroxide are used in the manufacture of soaps, paper, and synthetic fibers like rayon. A base like calcium hydroxide is used to manufacture bleaching powder. Bleaching powder is used as a disinfectant. Magnesium hydroxide is used as an antacid to neutralize the acid produced in the stomach. This is similar to the one you have taken to obtain relief from your acidity problem. Bases are useful to plants too. A base like ammonium hydroxide is used in the preparation of fertilizers like ammonium phosphate and ammonium sulfate. What's the matter, Sam? You look pale. Is something wrong?
I have overeaten, and now I am feeling some uneasiness in my stomach. What should I do?
This problem is known. A mild
Acidity.
base neutralizes the excess acid produced in the stomach and makes you feel relieved. In this lesson, you will learn about properties and uses of bases. At the end of this lesson, you will be able to define a base, explain the physical and chemical properties of bases, explain how indicators help to identify a base, and list the uses of bases.
Tell me more about a base.
Any substance that can produce hydroxide ions when dissolved in water is known as a base. For example, sodium hydroxide, when dissolved in water, dissociates into sodium ion and hydroxide ion.
How can one identify a base? Do they have any unique properties?
Yes, they do. Bases can be identified with their physical properties. For example, they are bitter to taste. But you must never taste a base, as strong bases are corrosive in nature and denature the protein.
What are these colored strips of paper? What are they used for?
These colored strips of paper are called litmus paper. Bases turn the red litmus to blue. Apart from litmus paper, we can use methyl orange. On addition of methyl orange to a base, like sodium hydroxide, the orange color of methyl orange changes to yellow, and when phenolphthalein is added to sodium hydroxide, it changes to pink.
Note it down.
It's slippery. It feels like soap.
Yes.
Bases feel soapy on touch. This is because they dissolve the fatty acids and oils from the skin, and it reduces the friction between your fingers as we rub them together. Due to this property, bases are used in the preparation of soaps.
What is this?
Bases are good conductors of electricity in aqueous solution. In aqueous solution, they release ions which conduct electricity. To prove this, let's perform a small experiment. First, we take 10 milliliters of sodium hydroxide solution and 10 milliliters of water in a beaker. Then, we take a cork and fix 2 carbon rods in it. Next, We connect the rods with an electric wire in series, along with a battery, switch, and a bulb. Now, we insert the setup into the beaker with sodium hydroxide. Finally, pass electricity through it. We can observe that the bulb glows. From this, we can conclude that bases conduct electricity.
Ouch! It's hot!
Behavior of these bases.
Chemical behavior?
Bases react with some metals, like zinc, and liberate hydrogen. For example, when sodium...
As we have discussed the properties of acids, that acid dissolve or acid react with metals to give hydrogen, right? And some kind of salt. So just like acids, bases also give the reaction.
hydroxide reacts with a metal like zinc. It liberates hydrogen gas along with the formation of sodium zincate.
I don't see any gas.
Yes.
How can you say it's hydrogen gas?
The liberated gas can be tested with a burning splinter, which is put off with a pop sound indicating the presence of hydrogen gas.
What's next?
Bases react with non-metallic oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base.
First of all, note this general equation. This is general equation, then we'll apply the reaction. General equations are being learned and then these are applied to different kind of examples. For example,
From this, it can be concluded that non-metallic oxides are acidic in nature. Consider an example. When carbon dioxide gas is allowed to pass through calcium hydroxide, it results.
now you can see here, this is base because it has hydroxyl ion, and this is non-metallic oxide, means any oxide having no metal. So this is non-metal, carbon dioxide is a non-metal. Base is reacts with non-metallic oxide, gives a kind of salt and water. And this also is what? This is the neutralization reaction. When salt and water is formed, that is why it is called neutralization reaction.